Many heavily populated cities across the world are currently experiencing vehicle and pedestrian congestion and accidents that could be eliminated or at least mitigated by implementing a different system of walkways. This presentation explores the possibility of such a system by considering the necessity of, different types of, and best approach to walkways that vertically separate vehicles and pedestrian traffic. Under the current system, pedestrians and vehicles both share the same horizontal plane, meaning both forms of travel are slowed by each other. This fact will only get worse as world population continues to soar and test our aging infrastructure. Not only does such overlap of travel mediums impede commerce, but this overlap contributes to fatal accidents. Congestion due to population concentration, which is shown in the graph, is not only a nuisance for those traveling, but also hampers commerce in and around large cities. Thus, any form of congestion reduction should be a priority for any major city. In the past, cities have employed several systems that vertically separate travel mediums in an attempt to reduce congestion. One such solution is the use of underground walkways. While having been employed in several cities around the world, the underground option comes with certain drawbacks. In order to make such walkways, one must rip up all road and utilities for an extended amount of time, costing tremendous amounts of money. In addition to underground, there is also the elevated option. Elevated walkways have been thoroughly used and proven in many cities. Some have even taken this option so far as to use a skywalk system, which consists of networks of above-grade interconnecting pedestrian walkways. In this way, a skywalk system does not merely augment the current walkway system, but re-engineers it as a whole. While elevated walkways still bears the cost of production, it avoids the cost and hassle of ripping up roads, piping, and electrical. The only drawback to this solution is that in certain instances it has the possibility to make clearance issues for traffic. There's even those systems like Hong Kong that have used both the elevated and the underground option. In Hong Kong, rather than supplementing the sidewalk, the city has totally re-engineered the walkway into an intricate network that changes the travel patterns of pedestrians so as to keep them away from vehicles. When considering any implementation, feasibility is always the motivating factor. Any planned system must seek to make cost as low as possible so that as many cities as possible can employ it. There are three main questions that one must answer about this system. How can it be made affordable for a city? Should elevated or underground be preferred? And to what extent should the system be applied, or where and when? With past solutions and feasibility concerns in mind, the best system is to use elevated walkways only at intersections. The use of elevated walkways will avoid the before-mentioned financial pitfalls of underground walkways, and while any such infrastructure overhaul is inherently expensive, this system will make the price tag feasible by avoiding extensive networks of new walkways such as the skywalk systems, in favor of altering the system only at intersections. While in most cases a simple elevated walkway that bridges the intersection where the crosswalk used to be is the best option, there are some exceptions. Some examples are as follows. In cases where an intersection does not warrant an expensive structure, the current system should remain untouched. Also, in some instances, overhead obstacles and clearance issues that would be created will force a city to use an underground walkway. And the issue that will most definitely arise is the fact that in some cases there is no room on the sidewalk to support a conventional overpass-like walkway. In this case, the elevated walkway must be built into surrounding infrastructure. In closing, this proposed system of elevated walkways at intersections constitutes a much-needed infrastructure improvement. By reducing pedestrian vehicle overlap, both modes of travel flow more freely and accidents are reduced. In addition, any future system should favor the elevated approach due to feasibility concerns. And finally, while certain cities may be able to afford an extensive system such as Skywalk, merely separating traffic mediums at intersections will make the system feasible for many more cities. Thank you for watching.